Where did we stop in the last class? We were talking about domain model, right? Yes.
We were discussing about the use case, the action bazaar.
Yeah, the domain model.
Yes.
Yes. So today, let's carry for our discussion. Let me check whether I've got the tool. Lot of tools coming in. No. Okay. Sorry, sorry. I didn't install the tool with Visual Paradigm. So I thought of doing it. Mm, In the last class, we were trying to understand how to create this domain model. That is where we have stopped. Okay, so we were talking about this action bazaar. So here we were trying to identify the entities or domain objects involved in this action bazaar. So that is what we're trying to do. Yes. So though I don't have a complete domain model for this, definitely I'll give you people this domain model diagram tomorrow. I didn't install that few visual paradigm which I thought doing it. Told we can give you the link as well. You can also try drawing this domain model if you're interested. So now we are trying to understand the entities involved in the domain. Now because of space issue, I took few entities. If you can check this, not all. You will find that here we have this rectangular boxes basically which represent that entity involved in the domain. I can say what are the item, bid, category, address, buyer, and seller. Have you noticed it here? For buyer and seller, I have created a superclass called as user. Okay. See, user class is a superclass. What are the common properties and behaviors which you find in the buyer and seller, you'll have them here in the user class. Yes. In this case, only this user, buyer, and seller entity classes are based on inheritance concept, I can say. Yes. Now, you see here, you see for both buyer and seller, you'll have address. Address is common for both the buyer and seller, and it is defined as a separate entity. If you can check this, it is a separate entry. If you can check this, and it is associated to the address directly. Sorry, it is associated to the user because both the types of users called as sellers and users called as buyers, they both will have address. It is added to the superclass itself. Yeah, yeah. And what is the association between the user and address? You see, when we talk about associations, this is not an inheritance association, right? Yes. How will you describe this association between the user and address? Yes. User has a address, which is a simple association, I can say. That is how you describe this association. User has a address. Sorry. User has a address, right? Oh no, I'm not talking about the tables and all now. Okay. Just we are trying to understand the associations here between the real world entities, I can say. Got it, Rajani? We're just trying to identify them. Later on, we'll see creation of tables. Okay. So when you talk about user and address, user has a address, right? And that is how you describe the association. You know what? Here again, when we talk about associations, we'll have cardinality constraints. Cardinality constraints, or we say multiplicity. What is it? What are cardinality constraints or multiplicity here? Yes. How will you describe this cardinality? When I say, if someone asks you, what is this cardinality, then what you'll say? Maybe at least to yourselves, you should be able to explain what is cardinality, right? Or multiplicity. What does that mean? Sorry. You know, cardinality means I can say that basically it is all about the number of objects involved in an association. Cardinality constraint, it describes the number of objects involved in the association here. Okay, it describes the number of objects involved in the association. So if you take this address and user, you see from the address perspective we have one address and there will be one user. Okay, there will be one address and one user. That is how you describe this association, right? One to one. One address object will be associated to one user object. User can be seller or buyer. Yes. Okay. Next, you see, let's talk about the other associations. The association between the bid and the buyer. You see, buyer and bid. How will you describe this association? How many objects are involved here in this association? Yes. So in this case, from buyer's perspective, you'll have one buyer placing many bids. A buyer can place multiple bids. Buyer can place bids for different items. Buyers can place items on, sorry, place bids on different items. Buyer can place many bids. So buyer can be associated to many bids, I can say. Yes. Okay. How about bids? From the bids perspective, how will you describe this association? From buyer's perspective or bidder's perspective, you can say, you can describe this association as one to many. One to many. Actually, I should have used star here, but what I did is, but by mistake, I added zero dot dot one. Have you noticed it? This multiplicity or cardinality is described using this one zero dot dot one is there. Now, what is it? It indicates that on the buyer side, one buyer will be involved. When it comes to bids, there can be zero or one, or actually it should be zero dot dot star. I'll correct it. It should be zero dot dot star. That means there can be zero, one, or more than one bid involved in this association. That means there can be zero or multiple bids. placed. You see, when initially buyer registers for this online shop, there won't be any bids placed, right? There will be zero bids initially when the buyer is registered. Later on, buyers can start placing the bids. Yeah, then the counting rises. Next, you know, similarly, if you consider item and if you consider item and bid, actually that again that number is misleading. Sorry, but between the item and bid, yeah, how will you describe this association between the item and bid here? Yes, the association between the item and bid.
One item can have many bits.
Yeah, that's right. One item can have many bids. That means it is one to many from item's perspective. From the item's perspective, item's point of view, it is one to many. So on an item, many bids can be placed. So how will you describe this association from the bids perspective here? How will you describe this association from the bids perspective? Yes.
Many to many.
From bids perspective,
Yeah.
it cannot be many to many. It is one to many. From the bids perspective, it is many to one. Many bids are placed on an item. Many bids, one item. If it is from item's perspective, it would be one bid, one item, many bids. One to many from item's perspective. It is one to many from item's perspective. Okay. So hope you people got it. So this is how you can describe this association. Next, how about item and category? The association between the item and category here.
Many to many.
Many to many. Yes. Here this time it is many to many. You see, when it comes to item and category, how will you describe it? You see, from the categories perspective, I can say that in a category, you can have many items. In a category, you can have many items, multiple items, many items. How about the items perspective? You see, from categories perspective, it is one to many. Listen to me carefully, all of you. Yes, it is one to many from categories perspective. One category has got many items. How about items perspective? When we talk about items perspective, you know, an item can belong to, it can belong to many categories. Yes, the item can belong to many categories. From items perspective also it is one to many. From items perspective also it is one to many. One item belongs to many categories. From items perspective it is one to many. From both the sides it is one to many. One item belongs to many categories. So this type of association is actually called as many-to-many association here. This is many-to-many association. That's okay. Let me give you an example to explain this. See, you'll find that, let's say you have a category called as mobile. It's a category, let's say. Let's say under the mobiles we have another multi other categories like you see Samsung, Apple, BlackBerry. Then under the Samsung you have the mobiles like Note 2, Edge, iPhone 7, etc. Don't remember BlackBerry models. Let's say back BlackBerry one. You see, if you check this here, if you take one of the phones, let's say Edge phone, I can say that this phone called as Edge, it belongs to Samsung category, and I can also say that here it belongs to mobiles category also. Am I right? Can I say that this phone also belongs to mobiles category? Of course, right? Not only Samsung. Yes. So here, you see, you may have another category. For example, let's say electronics. All these phones, they belong to this electronic category. Now, this phone called as Note 2, it belongs to how many categories here in this case? This phone called as Note 2, it belongs to how many categories?
3 categories.
3. It belongs to Samsung category, it belongs to mobiles category, it belongs to electronics category as well. All the 3 categories, yes. So, again, you see, if you consider a particular category, let's say Samsung category, you have 2 mobiles under it. In the category, you can have many mobiles again, right? You can have many mobiles. Yes. That is how we describe this association here. So this is how we describe a many-to-many association. So between the category and item, it is many-to-many association. Now, can you people give me some other example from many-to-many association? Can you people give me an example for many-to-many? I gave one example, item and category. Maybe not from this case study, from some other examples. Item and order. Okay. Okay. How can you describe it? Now, if you consider that an order can be placed for multiple items, yeah, you see, but actually, one thing we have to consider from a particular item's perspective, not in general. So, can we place the same item? Can we place the order for the same item multiple times? I mean, same item. Let's say you have some item with a particular barcode. Is it possible? But not the same font two times. You got the point? Not the same font two twice. Yeah, that's not possible.
You can give an example of grocery. For example, a store.
Okay.
Store can be one category, and then under that groceries.
Yeah.
And under that you can give some brand.
Okay.
For example, like Nestle or something. So under that, all different categories, all different items we have.
Okay. Yeah. So another example, I can say that you see student and courses they enroll. Right? You see, a student can register for multiple courses. And in a in a course, for a course, you can have many students. In a course, we have many students. From students' perspective, it is one to many. One student registering for many courses. From course perspective, see, in a course, there are many students. Okay. So this way, you have many to many association between these two objects here. And I can give you another example here. See, faculty and department.
Employees and department also.
Faculty and department, let's say. It is also very similar, faculty and department here. A faculty, see, may belong to or can teach to multiple departments, right? So let's say a faculty who teaches mathematics, say engineering, let's say it's an engineering college. The faculty who teaches maths can teach to different departments, right? They can be students of electronics, electrical, civil, mechanical. Yes, they can be associated to multiple departments here. Similarly, in a department, you'll have many faculties. Okay. Yes, in a department, you'll have many faculties. So this is how you describe a many-to-many association. Okay. Now, most of the associations, so this is how you're going to describe them. Either one-to-one, one-to-many, or many-to-one. You see, even the association between the item and seller. But before that, have you checked it? That one dot star, one dot star. You see, from on the category side, you have this one dot dot star. Yes, that is how you'll describe many-to-many association. On both the sides, you have this one dot 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 star. What it indicates? Can you people tell me what it indicates here? Yes. You see, in this association between the item and category, you'll have one or more than one categories involved. Even from the item's perspective, you see there can be one or multiple items involved in this association. Yes, one or more than one item involved in this association. So it is one to many from both the sides. That is how the association is described. Yes. Okay. Next, between item and seller also it is one to many. Okay. One item, sorry, a seller can place 0, 1 or more than one item for sale. A seller can place 0, 1 or more than one item for sale here. Yes. So these are the various entities or domain objects involved in this domain, Action Bazaar, online domain, and we have identified various associations. You see, we have identified the associations between these entities, I can say, the cardinality constraints as well. These are all the things which you did. Now, how this domain model helps us? Yeah. You see, first of all, the entities which we have identified, basically they represent the data, right? And we have to store the data related to these entities or entity objects in the database. We have to store it permanently in the database. And also, you need to work with this data on the Java side as well, not just in the database, but we need to work with this data on the Java side as well. Yes. So you have to represent these entities on the Java side as well as on the database side. Now here this presentation helps us to do this. Yes. You see, entities are objects that can be persisted into the database. In the first step, you'll identify entities. That is what we did. For example, entities in the Action Bazaar. So you see, we have identified some entities like this, right? Item, seller, category. That is what we did. Next, domain actors. You see, in this domain model, you have there are actors which play an important role. What are those actors here? What are the actors which play a role here? You know, domain modeling theory identifies 4 domain actors. What are they? Objects, entity objects. That is what we have identified. Relationships between these objects. Okay, we saw the links between various objects here. which objects are associated, which objects are related. We have identified it. And multiplicity of the relationship. After identifying the relationship or association, we need to also describe that association, how these objects are associated. Okay, in this association, how many objects are involved? Multiplicity or cardinality constraint will describe it. And the optionality. And what about this optionality here? What do you think? Cardinality we saw. By the way, what is this optionality again? Yeah. Sorry, just a minute, please. Just a minute. Yeah. So, what is optionality? What do you think? Any idea about optionality? Optionality is also similar to cardinality. So, optionality here it describes whether an object is optional or mandatory in an association. It describes whether an object is optional or mandatory in an association. Yes. So that is how it describes optionality. You see, now if you consider this association, Yeah, bidder, bid and buyer. I'm sorry. As I told you, when we talk about bidder and buyer, you say I gave 0 dot dot 1 in case of bidder. Bid, I'm sorry. It is supposed to be 0 dot dot star actually. 0 dot dot star. So 0 indicates that in this association, bidder is optional. You may or may not have this bid object. You see why? Because initially when buyer registers, at that time there won't be any bids associated to this buyer. There won't be any bids associated to this buyer, right? Yes. So that is optional. This way, in an association, we'll describe whether an object is optional, mandatory. Yes, that is what we do here. That is ordinality. Okay, I hope this is important. Now, we have identified the entity objects in the domain model. Next, you say, how will you represent these entities or implement this domain model? So, what you will do, you see, from Java developer's perspective, I can say that domain objects are closely related to Java objects. Yes, domain objects basically they represent real world objects, and our Java objects also they represent real world objects, right? I can say they are very much closely related to Java objects here. Yes. So you see, like Java objects, domain objects can have both behaviors and state. The category domain object probably has name, creation date, modification date as attributes, right? Similarly, say category probably also has behaviors of being renamed, modification date updated, right? So there are likely hundreds of instances of category domain objects. Yes. So we have to represent this real world objects, the domain objects in the domain model as Java objects. And that means when we talk about Java objects, of course, we have to define a Java class for it, right? We need to define a Java class for it. Yes. Okay. Next, relationships. When it comes to relationships, how the relationships are represented here in Java, how the relationships are represented in Java. In Java terms, or in terms of Java, yes. So ER diagram is different again. I mean, they look similar, but not same. So in terms of Java, you see, a relationship is manifested as one object having reference to another. One object having a reference to another. Yes, that is how we represent associations in Java, right? Using object references. To describe the association between two objects, what you will do to describe the association between the objects, what you will do, okay? You'll have the reference of one object in another object here. Yes. You know, always using references, we represent associations. For example, you see, if bidder and billing objects are related, so there is a probably a billing info instance variable in bidder. Yes, you'll add a billing info reference variable in bidder object, I can say. Yeah. A bidder instance variable and billing info, both. We can do that. Yes, it is possible. So typically, you see, objects are nouns and relationships are verbs, such as has a, is part of, is member of, belongs to, and so on. That is how you describe relationship association, right? Yeah, they're verbs. Yes, has a, is part of, is member of, belongs to, and so on. So item is placed or posted for sale, right? Who places item for sale is the seller. Seller posts item for sale. So there is association between item and seller. This will be describing association. Yes. So um, next we have discussed about this multiplicity and cardinality already. Okay, but on the database side, how will you do that? I didn't discuss it. I didn't mention about it here in the PPT. But let's try to understand this. Okay. So when it comes to the database side, okay, on the Java side, for example, if you take this association item and bit, so you will define an item class because we have to create item objects for this item entity, and the bit objects will be represented here in Java as bit objects here also. You'll define a Java class for this, right? Yes. And the association between item and bits, yes. You see, from the items perspective, this association is actually one-to-many association. From items perspective, this association is actually one-to-many association here. Yes. So how will you represent that one-to-many association here on the Java side? Can you people tell me? How will you represent that one-to-many association on the Java side?
We should have the reference of the many item in the one. Whatever is the many, we should have the reference in the.
Yeah. So how that many will be represented here in the item class? That association.
List.
Yeah, you can use a list or a set. Okay, here I'll be using set. Set would be more appropriate. We use collection settings. You see, in the item class, we'll have a reference to set of bit objects. All the bits associated to this item. I can say that item object holds the reference to the collection of bits associated to it. Item object holds the reference to the collection of bits associated to it. Okay. Now, from the bits perspective, you can also represent this association. It would be many to one in this case. here we'll have a reference to only one single item here. We'll have one single item reference because bit can be placed on only one item this time, right? So now from the bits perspective it is many to one. So many bits will be having the reference to the same bit object, I can say. They'll be having the reference to a single bit object, same bit object. That is how you describe this association on the Java side. Now how will you do it on the database side? So okay, how will you do it on the database side? Now you tell me on the database side what you will do.
So primary key, foreign key.
Primary key, foreign key. So first of all, to implement this relationship here, how will you start? You will define a table for the items. See, table item to represent that the item entity here on the database side. We'll use this table. We have to create a table for that item entity. And similarly, you see in the item table, you'll add the columns like item ID, which will be a primary key. And then we'll create a table for the bid as well. You'll have a bid ID here, which is a foreign key column, sorry, primary key column. Now these are the two tables. Now you have to describe the association between these two entities. So what you will do? You have to describe the association between these two tables. So what you will do?
In item table, bid ID is a foreign key. In bid table, item is a foreign key.
In the item, okay, let me describe it. You see, in this case, can we have the foreign key column in any table? I can say no. The foreign key column, it can be only in the bit table now. We can have the foreign key column only in the bit table. Yes. So in the bit table, you will add a column that is your foreign key column. It refers to the primary key of the item table. We can say foreign key column references primary key PK of item table. That's it. This way, you'll describe this association here. Yeah. So the bit is associated to which item, that item ID will be there in the bit table. And this item IDs will be in the item table first of all. Yeah. So this way, you see, the domain model helps us to identify the entities and see the data which we can store here in this application. Okay, fine. Let's try to implement this domain model. Let's try to implement this domain model.
Sir, I have a question.
Yes.
From bit perspective, one-to-one relationship, like from one bit has one item.
Not like that. From bits perspective, it's many to one. Many bits can be placed on same item. That means different bit instances will have the reference to the same item object. It will be referring to the same item object. Mm, the bit is placed for same item. Many to one. Many bits placed on same item.
Yeah, okay, sir. But in class bit, you represented
Yeah, this is a class.
sing.
It's not an object, right? So later on, you'll create objects for this class. So where you have several item objects, and the several item objects will have the reference to the same bit object. Sorry, you'll create several bit objects. You'll create several bit objects. Several bit objects will have the reference to the same item object here. Yes.
Okay, sir.
Several items will have the reference to the same bit. Yes.
Okay. Okay, thank you.
You have to think about it from instances, objects perspective. So multiple objects, bit objects will have same item object reference. They'll be referring to the same item. Yeah. Okay. Bit means, yeah. What you understood about a bit? Tell me, Rama.
Sorry, sir, that is wrong window. I have wrongly sent that to you.
Okay. So bid is nothing but it contains that the bid price, how much a buyer, a bidder wants to buy that item, for what amount the bidder wants to buy that item. Yes. So anyone can involve in this in auction, right? In each bidder can quote their amount to buy that item. Yes, it's their wish. Fine. That item, that quote, that amount, that bid price, it will be mentioned here in this bid object. Yeah, we'll see that now. So let's start implementing this domain model now. Yes. Sorry. Okay. Now I'll be creating a package here and be using some standard structure for it. Com action mother com dot action bazaar dot persistent. So this is the schema name. Sorry, package name will be using. Now let's define a item class here and a bit class. So now we have to identify the attributes for the bit and items. So what I'm going to do is here, I have those attributes, I'll just copy them. Okay. Most common stuff I'll be copying it. Okay. I'll make this item class instrument serializable. So what are the properties? Let's have a look at this properties quickly in the outline. So on the right side you have an outline. If you can check this, it will give you the details about the properties. First of all, you can check this. So what are the properties? Item ID. See here on the on the right side you can check this. Item ID. We'll see it without annotations first of all. Okay. Yes. See, just check this properties and its data types. Item name string, created date, date type, initial price, big decimal type, bit start date, it is date type. You see here Now let's check this mappings first of all. First, we'll start with item class. I will annotate it with entity. So once again, what is entity doing here? Yes,
It specifies that serializable has the resources in the database.
it indicates that this item class objects are something special. How they are special? The entity object state, this entity class object state, it is persisted to the database server and they represent the records in the database server. They represent the records in the database server, right? Okay, next we have to map this map this class to the table. So for that I use table annotation. Table name equal to item. That's it. Next, you see these are regular annotations. ID column. You see each property is mapped to the column. But have you noticed it, especially on the properties which are of date type? The annotation at the rate temporal is used. Okay. So here temporal is used. I can say. Okay. Only on date types you'll specify it, temporal. Okay. Yeah. The properties which are date type. So we have created date. You see bit start date, bit end date. So on this item, when item is posted, you see the bit start date, the auction start date, end date, they're specified here. Okay. So now what we'll do next, sorry, let me add getters and setters for this. Okay. I'll add getters and setters. What's next? We got getters and setters. Similarly, first let me add the properties for the bits also. So there won't be many properties for the bits. We have three properties here and make this bits class implement serializable interface. Let me add getters and setters. Okay, so what are the properties of bit object here? Let's check this one in the outline. You see, bit ID, bit price, and bit date. So the ID of the bit, what is the bit price the user has quoted here, and the last thing, the bit date when this bit is placed. That is also important, right? Yes. Next, you see, each property is mapped to the column. Then they're very regular annotations. I'm not going to explain it again. Let me add entity here as well as the table annotation. Table name equal to bit. That's yes. The table names, the items and bits. Bits and items. Okay. Now we have these two entities. So in the item class, I'm going to add a reference to the bit. How item will be with on an item multiple bits are placed. So item object will have the reference to all the bits which are placed on it. This way. Item C holds a reference to the associated bits. And for this bits property, let me add a getter and setter. Get bits and set bits. Simple getter and set. Okay. Now this bits property in this item class, what it is representing? Yes. What it represents, this bits property. The bits property, I can say it represents the association between item and bit, right? It represents the association between item and bit. You know what? Here, it represents what type of association? One-to-many association. So we have to specify those details to the Hibernate framework. So simply I will add this annotation @ one to many on top of this bits property. Okay. So because this bits property here, it represents one to many association. You see, here we have added this annotation @ one to many. On the Java side, this is how the association is represented. How about the database? On the database side, how the association is represented? What do people think? How this association is represented on the database side? On the database side, foreign key column is used. Right? On the database side, foreign key column is used. So, you see, you have to also provide these details to the Hibernate framework. How will you provide the details about that foreign key column? Actually, in Hibernate framework, that foreign key column is called as join column. Join column. You'll add this annotation join column and you'll specify that foreign key column name. So what is that foreign key column name? I'll show you. Here I have this column details and I'll show you the tables as well. Just a minute, please. I'll give you this table schemas also. You can make use of it. Okay. Yeah. You see, in the bits table, we have this item ID column, which is a foreign key column here. Okay. That item ID column, which is in the bit table, is specified here. Item underscore ID. That's it. So this way you'll provide the join column details. Why we have to provide the join column details here this way? What do people think? Why we are providing all these details? Because you know what?
Show the one to
Yeah.
many relationship.
No. Why we are providing these details? Who will use these details? That's my question.
It helps. It acts like a documentation for ourselves and for the users who see this.
No. Actually, this is mainly used by the Hibernate framework. Hibernate framework is supposed to manage these associations for us, interact with the database, everything, right? So Hibernate is responsible for that here. So Hibernate framework will be managing this association for us. Okay, Hibernate framework will be using it. All these details, Hibernate needs it because you saw in the last class, did we establish the connection? Did we construct a query? What we did nothing. Who is taking care of all these things? Who's taking care of all these things here? Yes. Yes. Hibernate framework is taking care of it. Am I right? Hibernate framework is taking care of it. Yes. So we are providing the details to the Hibernate framework. So what's the next thing we have to do here? Yes. Can you people tell me? We have to register this entity classes with the framework, right? We have to register this entity classes here with the framework. In the Hibernate util class, you see we have that configuration object, right? So we'll be registering it here. So we have a item class, we have bid class, okay, item and bid. Now the next thing is actually these tables are in a different schema, action buzzer schema. I want Hibernate framework to use this schema. So what are we supposed to do? So where we need to make these changes here? Yes. Yes, you got the question right. here you have to make the changes in the Hibernate configuration file. Forgot? You have to do it here. You want framework to use action buzzer schema, that new schema which you got instead of test schema. So what I will do, I'll make changes here. In this configuration file, instead of test, use action buzzer. Okay. And now let's test this association. Okay. Here the schema name I've changed it to action buzzer. Here I won't use product table. Okay. I've just count. I won't use product class here. Yeah. Now let's test this associations. Okay. So let's see how Hibernate helps us in managing this associations. Test 1 to many. Again, you leave a session factory session here for this purpose. Now see here, we'll fetch the item records based on the ID. Sorry. What are the item IDs which you got here? Triple one. This is one of the items. Okay. We'll close the session and close the session factory itself. Now, okay, what if I want to fetch the associated bid objects here? What we have to do? See, this is very simple. If you want to fetch the associated bid objects, straight away, what you can do here, sorry, you can call the getBits method, which returns set of bid objects. We'll try to iterate through it. Straight away, just call that getBits method, getter method on the bits property. We have a bits property in the item class, right? We have a bits property in the item class. Just call this getter method. That's it. The rest of the things are taken care by the framework. It will fetch all the associated bid objects here. I can say yes. So let's read the bid details. Okay, bid ID, bid amount, bid price. So if you were to use JDBC API, then you have to write a query appropriately to also fetch this associated item details. Okay. Let's see this. Now let's try to run this code here. Oh, we have some issue. Okay, yeah. It says we are providing ID of wrong type. It is providing ID of wrong type, I'll tell you. Actually here in the item class, that item ID, we have specified it as long type. Long type. So this number should be prefixed with L, sorry, suffixed with L. Okay. If you want to make it long type, because it's a long type, right? It's taking long type value. You have to suffix it with L. Yes. That is what it is expecting here. Okay. You got the item as well as the associated bit details. See, don't you think it is so simple here? Yes. Hibernate makes it easy for us to manage the association. Yeah. So is it clear for you people, all of you, what we did here? Anyone got any questions in this regard? Yes. Okay. So shall I assume that this is clear for you people, all of you? Okay, good. So now we have to also implement the other entities. We have other entities also which we need to implement here. Yeah. So meanwhile, I have a task for you people. Okay. You got that classic model schema, right? Which I gave you in the MySQL tutorial. So will you people try to create entity classes? Okay. Identify the associations between the tables, cardinality or multiplicity constraints, create entity classes appropriate in Java, and map them to the tables. Will you people try that, all of you?
Can you repeat again, please?
Yeah, you have what we did here in in today's class. So mapping entity classes to the tables. So you don't have entity classes, you only have tables in that schema. So you have to create entity classes, map them to the tables. Identify that what entity classes you can define for that tables which you got in that schema, and map them. Do this mapping, object relational mapping we did, and try to work with that schema from the Hibernate application. Yes, create a Hibernate application for it in simple terms. Got it? So we have only schema, right? Classical model schema. Try to create entity classes for them. And I want a Hibernate application to access that data, to interact with the database schema, the classic model schema, and work with it. Yeah, from the Java application. So will you people try this, all of you?
We need to do, sir, like right now we did for item and bid, right? Which one will do in that example?
For all the tables. Identify the association between the tables and try to appropriately work with it. Tables on the Java side also.
Like item category 1 and buyer sell, like
Whatever you have
buyer.
in the schema, I'm not bothered about the table name. You know what
Okay.
tables you have over there. Yes. What tables you
Yes.
have, you know that. So create entity classes for those tables in the Java application. Try to work from the Java application, fetch the records which are in the classic model schema using Hibernate application. Using Hibernate, you have to interact with the database schema, work with the product table, tables in that schema. Still any questions?
Can you give me a glance, sir, like points, what we need to do exactly?
What we need to do exactly? Okay. Um, okay, you have that schema, tables, right? All of you have an idea about the tables. Now, I won't tell you in that way, but this is how I'll explain it. Write a Hibernate application, okay, a Java application which uses Hibernate framework. Write a Java application which uses Hibernate framework to interact with the classic model schema which you got, to fetch the data, to add the data, to update the data, whatever you want to do. That's it. Okay. Yes. You try this.
Okay, sir, thank you.
Yeah. So
Sure, can you please share the code today's class?
Okay. Okay. Yeah. So I'll stop it here today. Let's meet tomorrow and we'll continue. Thank you all. Bye-bye.
Do we have a class tomorrow?
Yes, we have a class tomorrow. Yeah. Classic model schema means I gave you MySQL tutorial. Okay, I guess you missed it, Rama. Yeah. Yeah. Krishnaveni, just share this classic model tutorials with Rama. Okay. You have that classic model schema, right? Yeah. Please share it with Rama. Okay. Fine. Thank you. Thank you all. Bye-bye. We have a class tomorrow at the same time. Yeah. Thank you. Bye-bye.
Thank you.